This is question 1 of Exam 3 practice. Question 1 is actually a collection of small bits of questions, and it says each part is independent of the others. First question, let x be the size of a house in square feet, and y be the amount of natural gas used in therms during the months of October through April. The regression equation is y hat equals to -5 plus 0.017x. The 22 houses range from 1,200 square feet to 3,500, and so on and so on. And the question is, predict the monthly gas usage for a house of 2,500 square foot, and the question is, justify your answer. And this question is actually made to mislead people, because it's giving you all these unnecessary information, but you have to know that when it comes to predicting something, that's when we use the regression equation. Okay, so regression is used to predict. So we only have to use this equation with x being plugged in as 2,500. So if you do the calculation for this one, I actually did it a moment ago, and it's 37.5. Okay, and therms is the unit, thermal units. Alright, now second question is, what range of values can correlation coefficient assume? This is like a basic knowledge test. Like, we know the correlation coefficient, if it's 1, it's 100% correlated. If it's -1, it's also 100% correlated, but with the downward slope, right? And anything in between is some correlation. If the correlation is 0, then there's no correlation at all. And we know that the Pearson correlation coefficient R can only be a value between -1 to +1. So you should write your answer as -1 less or equal to R less or equal to 1. Okay, so that these are the ranges of values for the R. Okay, now the next question, 41.8% of variation of y cannot be explained by the regression equation. What is the correlation coefficient? When you see these types of questions, when I say these types, notice the words variation and explained. Okay, and that should immediately make you remember that the R squared, which is computed by the Pearson correlation R squared, that's why it's called R squared, and that is the variation of y that can be explained by the regression equation. And you have to be careful here, because for this question you have cannot. So what you need to do is you have to get the value of R squared not as 41.8, but 1 minus 41.8%, or 0.418, which is 0.582. And because this is the value of R squared, the value of R, the value of the correlation coefficient, should be the square root of 0.582. Okay. And another thing that you have to be careful is that it doesn't have to be positive. It could be plus or minus. That's the tricky part. Okay. So that's the value, and I actually did the calculation, and it's 0.763. So it's plus or minus 0.763. Okay. So that's a tricky question. Cannot, so you need to do 1 minus, and then when you solve this, when you take the square root, you need a plus or minus. So it's either positive 0.763 or negative 0.763 for this much of the variation to not be explained by the regression equation. Okay, part D, if a set of paired data has a correlation coefficient of 0.550, what is the minimum number of data pairs needed to reject the null rho equals to 0 using 0.05 significant level? Well, for this you have to use the row test, and you need to use the row table. And here's the row table. And as you can see, for this significant value 0.05, there are different values of critical values, and we know that if the Pearson row is closer to 1, it becomes significant, right? So if your R value is bigger than these values, then it becomes significant. So for example, if you had degrees of freedom 5, then R value 0.550 is not as significant as 0.7545. So with this level of significance, what we have will fail to be significant. Okay. So therefore the next question is, since when does the value 0.55 become significant, or it becomes bigger than the critical value suggested? And it's right here. So our value 0.550 is bigger than this value with degrees of freedom 12. Therefore, this is the case where we can actually say that 0.55 is significant enough that the two variables are correlated. Okay. So rho equal to 0 means there's no correlation, but the row test with degrees of freedom 12 has critical rho value as 0.53, was it? 0.5324. And hence it is the smallest degrees of freedom that makes 0.550 significant. So that's a good thing. However, they're asking for the number of data, right? Or the lines of data, because usually when they say data, it's really data pairs. Okay? So minimum lines of data, or minimum number of data pairs, should be obtained from the degrees of freedom. And you have to know that for row test, important, for row test, degrees of freedom is defined as n minus 2. Okay. So using that, we know that n minus 2 has to equal to 12, which means that n must be 14. So the answer would be, we need at least 14 data pairs for R equals to 0.550 to be significant. So this is a bit tricky because it's reversing the role of the usual row test. Usually you're given the n and the row, and you have to find out whether there is a correlation or not. But here it's the opposite. It's you're looking for the n where this becomes significant. All right, part E, this is a really simple question. Order the correlation coefficient from the strongest correlation to the weakest correlation. And it's really the absolute value. If the absolute value is the largest, it has the strongest correlation. So here, 0.737, the absolute value of this value, which is positive 0.737, is larger than any of the other absolute values, right? So this would be number 1. And the next biggest value is 0.681, so that will be our number 2. And then the absolute value of this is 0.025, which is less than 1.124. This would be number 3, and therefore the weakest one will be number 4. Okay, so these types of questions, if it's on the exam, it's just there so that you can have some freebies. Okay, what are dummy variables, and give an example? Well, dummy variables are values of 0 or 1 assigned to a categorical variable. For example, male, if a data has male and female and the gender does affect the prediction, we can encode male as 0 and female as 1. Okay, so that's an example, right? So those are what dummy variables are. Okay, and there are some other more complicated cases. So here you don't have to write this, but you know, for colors yellow, blue, and red, let's say you have the same product but different colors, and some colors sell better than the other colors. In that case, we can encode using 3 dummy variables, as y would be 1, 0, 0, b could be 0, 1, 0, and r could be 0, 0, 1. So you can use dummy variables to encode a characteristic as a number, and it's a very powerful idea, because that means even if your data has categorical things that's affecting it, you can incorporate it into the regression without any problem. So that's a very powerful idea. Okay. Okay, so what is the purpose of a scatter plot? Well, you know, when you have a scatter plot, sometimes it gives you like a positive relation or a negative relation, or it's just scattered everywhere and there's no correlation. And if you see some kind of a correlation, then you can talk about regression lines. If there isn't any, then you don't use anything, right? So the purpose of a scatter plot is more like the purpose of the scatter plot is to find the linear to find correlation between variables. And that's the to see if there are correlation between variables. That's why you want to do a scatter plot. Okay, this H, I basically had the same question here. So please try this on your own. So I guess H is not that important, and that's it.